Alright, in this video we're going to talk about Unit 10, Objective 4, Arc Length. With arc length, basically what we're going to be doing is integrating our distance formula. So you hopefully remember that the distance between 2 points is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. That's going to be the basis for what we want to do here as far as our calculus is going to be concerned. But we're going to kind of change some things. If we look at x2 minus x1, that's just going to be the change in x. And y2 minus y1 is going to be the change in y. Well, in calculus, we have special words for the change. It's the rate of change, it's the derivative. So if we're taking the derivative of a function of x in terms of x, we kind of get a dx over dx, and we can get over here a dy over dx. Now we know dx is just going to basically be 1. So if we think about turning this into some calculus, we can say that our arc length is going to be equal to the integral, because we want to change or add up all of the changes of our distances. So integral from a to b of our square root of that dx over dx, that x2 minus x1 squared, so it's 1 squared, so it's just 1, plus y2 minus y1 squared is just going to be dy over dx squared with respect to x. So that's how we're going to find arc length for a traditional explicitly defined function. We can also do this with parametrically defined functions. So if we are doing this with parametric, we're not going to have a dx dx because everything's going to be in terms of time. So we would have a dx dt and we would have a dy dt. So if we were doing this parametrically, we're going to integrate from a to b of the square root of dx dt squared plus dy dt squared. And then that would be with respect to t. So we're either going to be integrating the distance formula in terms of x or in terms of t, which means we're either going to do 1 plus the derivative of y or the derivative of x plus the derivative of y squared, and we take the square root. So let's look at one quick example, and then we'll call it quits on the video. Let's find the exact length of the curve y equals 4 times the square root of 2 over 3 times x to the 3 halves power minus 1 from 0 to 1. So we want to start by thinking about taking our derivative of y. So dy dx is going to be equal to, we drop our 3 halves, we have our 4 radical 2 over 3x, this is going to become a 1 half. The the derivative of that negative 1 is 0, so we can simplify a few things here, and we're going to get 2 radical 2x to the 1 half power for our derivative. But if we think about the arc length formula that we want to use, it's not dy dx that we're worried about, it's dy dx squared. So if we square this, we get 2 squared is 4, square root of 2 squared is 2, multiply those together, we get 8. X to the 1 half squared is just going to be x. So when we find our arc length, we're going to want to go integral from 0 to 1 of the square root of 1 plus 8x with respect to x. So we need to rewrite that as 1 plus 8x to the 1 half power. So we can use a u substitution because we have parentheses. So our u is going to be equal to 1 plus 8x. du is 8 dx. We don't have an 8 dx, so divide by our 8. So 1/8 du equals dx. So we go back, rewrite this as the 1/8 times the integral. We need to change our limits of integration If we put 0 into our relationship, 0 times 8 is 0 plus 1 is 1. If we put 1 in there, we're going to get 9. So we're going to be looking at 1/8 the integral from 1 to 9 of u to the 1/2 du. So we're looking at 1/8 times increase to 3/2, so 2/3 u to the 3/2 power from 1 to 9. So 9 to the 3/2 is going to be 27 divided by 3 is 9 times 2 is 18. And then 1, plugging all that in, we're going to get 2/3. So that's going to be 1/8 times 54/3 minus 2/3, which is 1/8 times 52/3. So we can simplify and say divide that by 4 to give us 13, divide that by 4 to give us 2. I'm going to get 13/6 for our exact length of that curve from 0 to 1. So what we want to think about is integrating our distance formula. If we are defined with an explicit function that we're used to, it's 1 plus the derivative. If we are defined parametrically, it's the derivative of x and the derivative of y. So that'll do it for this video. We'll see you in the next one.